past exam question, and it's a differential equation which involves some trigonometry and the double angle rule will be applied. So let's have a look at this. We've got the variables x and theta satisfying a differential equation, and we've got sine half theta dx d theta is equal to x plus 2 bracket cosine 1/2 theta for 0 is less than theta is less than pi, and we know that x is 1 when theta is 1/3 pi. Solve the differential equation and obtain expression for x in terms of cosine theta. Well, in this case, my first step is to look at this equation here, and I am going to bring across to the left-hand side 1 over x plus 2, and dx d theta equals cosine 1/2 theta over sine 1/2 theta. My next line I will have is 1 over x plus 2 dx equals cosine 1/2 theta over sine 1/2 theta d theta. So now we are going to integrate these both sides. So now on the left hand side we will have ln x plus 2, and on the right hand side, now this is quite interesting actually. If we look at this here, I'm just gonna put a little box up here. We know that if we integrate something where we've got f prime x over fx, that will be equal to ln fx. Okay, so we hopefully you can see that we have something like this here. So when I integrate this, I'm going to have ln sine 1/2 theta and I'm going to have a 2 in front of the ln. Now you might wonder why that is. Well, if I were to differentiate ln sine 1/2 theta, I would end up with 1/2 cosine 1/2 theta over sine 1/2 theta. And the fact that I've actually only end up with this in this green circle I've got over here indicates that I must have had something to cancel out this 2, which is why I put this 2 in here. Sorry, something to cancel out that 1/2. So I must have 2 ln sine 1/2 theta plus c. Okay, now the next part of these equations, after we've separated the variables and done this and integrated, then we want to insert these values of x and theta. So ln 1 is x, so ln 3 is equal to 2 ln and then sine 1/2 pi over 3, so sine pi over 6 plus c. Now another way of writing this is ln 3 is equal to Now, sine pi over 6 is 1/2. So, just write that here. So, pi over 6 equals 1/2. Okay, so I'm going to use this. So, it'll be ln 1/2 squared plus c. So, next line, ln 3 minus ln 1/4, because of course 1/2 times 1/2, or 1/2 squared is 1/4, equals c. Now, using my log rules there, I'm going to have 3 over 1/4 equals c. So ln 12 equals c. Okay, now let's carry on over here. We're going to obtain an expression of x in terms of cosine theta. So, what have we got? We've got ln x plus 2 equals 2 ln sine half theta plus ln 12. Okay, my next line would read ln, using my log rule, I'm going to pull this positive ln over 12 to the other side, and I'll end up with x plus 2 over 12, using my log rules, is equal to ln, and again using my log rule, sine 1/2 theta squared. Now, since I've got a log on both sides here, it's just ln something equals ln something. I can remove those ln's and have this here, sine 1/2 theta squared. Now, at this point, I'm going to use the double angle rule. So I'm going to use this, cosine 2a equals this. Now, I'll just write it down here so you can see cosine, and in this case, 2a is going to just be theta. Cosine theta equals 1 minus 2 sine 1/2 theta squared. Okay, so that's what we've got. Now, you can see, I hope, that we need to do some rearrangement here to indicate what we've got there. So I'm going to have cosine theta minus 1 equals negative 2 sine 1/2 theta all squared. And I still haven't got quite what I need over here, so I'm going to divide by negative 2. That will give me 1 minus 1/2, minus cosine theta over 2, or 1/2 cosine theta, I guess, equals sine 1/2 theta all squared. So that's what I'm using. So my equation will now look like this. Is equal to 1/2 minus 1/2 cosine theta times both sides by 12. That's a 2 up there. Equals 6 minus 6 cosine theta, and then finish it off by moving the 2 across the other side. So I'll have 4 minus 6 cosine theta, and that is that question, full 8 marks, all sorted. Alright guys, I hope that makes sense. Do ask any questions in class if you don't understand this, but it's a good one to have a look at. Application of double angle rule, also some of our log rules which we're a bit hazy on. Alright, take care.